Hey, what's up, guys? So this is, I'm pretty confident now, after all these times, that this is the actual last version of what I'm doing with the electronics. I just have a couple wires that I have to route properly. So as you can see, I added another power supply. That's a 48 volt Meanwell right here. That's going to be powering the X and Y stepper motor. Those are the only thing I haven't gotten completely configured. I'm going back and forth with Big Tree Tech and trying to figure out why that is. But I'm hoping that that works out. It's got the 2209s in it right now, so that's the only thing I would have to change. I just have the motor power wired in, but nothing is going to it right now. I have it jumped for the board power on the 2209s currently, but that's so that I could finish everything else. So I did get the other beacon, so that's in there right now. I did end up doing a and I'm gonna open this and put this. All this wiring is gonna be cleaned up the rest of the way. It's a lot better than it was, obviously, but it's gonna be, you know, like completely done properly. But so the chamber heaters, I got them all working. What I ended up doing was using this signal wire for the MOSFET for also the 120 chamber heat SSR. So the same signal wire signals them both at the same time, because I was having trouble having two pin definitions and clipper, and honestly I'd rather keep the extra heating channel open that I could use for something else. This one does have a good amount. I have the bed heat coming out of the bed heat on top, so I have 4 here. So I have the extruder, and I'm using my case light LEDs out of that, and then I also have the bed heater signal wire. So there's 3 of these being used anyway: the hot end, the bed, and the chamber heat. So I have 1 left, even though I'm using all this stuff, which is nice. So that's that. You see I relocated the MOSFET to put the power supply in, because that would fit up there and that wouldn't, and that's about it. I just did a little bit more cable management, and you know, I'm not quite done because I just did a couple modifications, and then I'm going to make a new mounting bracket for the beacon. I'm going to make part of it. I'm going to CNC machine part of it, because the one I had before was meant to be temporary. It was made out of PC, polycarbonate, which is, I mean, it's good in high temperature. I'm going to use PPS, the high temperature nylon, because it has a much higher melting temperature, and this is going to be extremely hot inside. For any average printer, this polycarbonate is very good, but for these kind of temperatures in the chamber, you know, like up to 200 C at the high end, which I don't know how often I'll go that hot, but you know, the PPS won't melt at that temperature, so that's why I'm going to use it. But that will be done shortly. I'm just gonna take some measurements and machine them out for it, and then the beacon I'm gonna mount. And I haven't decided whether I'm gonna use it all the time or not. But what I did do is put a mechanical limit switch. Not like a clicky probe. I do have a clicky probe. I thought about using that, but an actual limit switch up here on the side. That's for the bed, and it levels well with that. So it's honestly, I may end up using it, and then I'm going to use this for the camera, because the camera wire got burnt out with one of the boards, and then I changed the power supply, the main power supply. So you see, I can adjust, I can control temperature. Temperature. I can control the amperage and the voltage. So it's kind of like, it's a power supply, but it's almost like a benchtop, but it's not. It's actually an expensive one. That's not like one of those $30, $40 ones. That thing was like 140 bucks. So it's a good power supply, and it's able to handle, when I turn on the chamber heat, I'll show you, it's giving out like 25 amps. And the 120 volt is not even coming from this. It's going right from the wall. It's just the signal wire. So this 24 volt is only supplying the other 2 chamber heaters and the 5 volt signal wire. That's it. Let's see. Let's just put it up to 50 degrees. Oh, shoot. I didn't finish hooking them up. That would help. Hold on 1 second. I wanted to route this cable first. I just need to put it in that channel. I'll do that after. I can stick it underneath these. Just try to get it routed, the stuff that I would have to disconnect it again for. Okay, and then that'll just go in there, and then I'm going to put it behind these. I'll just do this so I can show you guys how much actual amperage it's drawing. But so I don't know if that other power supply was not reliable enough, and that's why I'll pull that slack into the channel, and that's why I was having problems with the boards. I don't really know. I mean, what I can say is it's working right now, but I haven't changed. Well, I actually no, that's not true. I did change something else, which I'm glad that I thought of that because I highly recommend it. I did a separate switch, a separate power switch, just for the board itself. So I'm sorry, I meant to zoom out. I did a switch right here. This goes to the board only. That's the only thing it connects to. So that's going on the 24 volt power on its way into the board. So I shut this and then I shut this because this is also powering. Well, first of all, the switch is going to the 120, which goes into this 1 to 5 times 3. So the line and neutral and ground are each broken off into 5. So I have the 5 outputs. One is going to another power supply for the cooling system and another direct 120 for the cooling system. So that's all turned on and off by the printer. Then it's going to, and it goes to the filter before any of that. So first it goes into the switch, out from the switch to the filter, from the other side of the filter right into this splitter, and then the splitter out to everything else. So, and then I have one set going to the other power supply, and there's obviously, you know, the 2 power supplies, 3 power supplies, and then what else am I powering with it? Oh, the 120 volt bed and chamber. So it gives me a good weight. These things are great. Those are, I mean, the Wagos are good, but these are much better for this type of thing. But obviously I use the Wagos too. Those were great for the fan wires because I have put 3 fans for cooling this. The Pi is the Raspberry Pi is wired to the pins, but is the only one that's on all the time. So it's nice and quiet. But these fans, as soon as I activate any heat or any stepper, they go on. So I'll show you that. Let me finish hooking this up so I can show you what I was saying with the heat. But so anyway, so you know that signal wire will work for multiple sources. It's only a low voltage, low amperage. It's a very low current and power output. Input that they need. It's just enough to tell them to turn on, which I literally tested with my benchtop power supply. I ran a wire over here when I was testing the MOSFET and the SSR and just ran 5 volts only, and they turned on. I didn't try it any less. It may have turned on with less, but they turned right on with 5. Okay, now they'll turn on. There we go. So you see I have the MOSFET on. You probably saw it light up, and then the SSR right here in the middle is on. I have to label that wire too, but anyway, so the chamber heat's all working. I'm very happy about that. You see it's using 26 amps, 27 amps almost, 26.8. But it's still at 23.7. It's right around 24 volts because this is a really good power supply. It's regulating it very well. So now I don't have to worry about any electrical issues as far as that. But I do recommend doing this switch because I did that and the power supply at the same time. So I have no idea which one fixed made it not burn out a board, because before the boards were burning out with the 1200 watt. This is 1000 watt. So it's not that it can't have a higher wattage. That's just for current when you need a lot of current, which I am going to need a lot of current with all this heating supplies. So obviously, I mean, it's using 26 to 7 amps already just with the chamber, and the bed heat's not on, the hot end's not on, the steppers aren't moving, so it's going to need a lot of amperage. Plus then the water cooling's not on. Nothing else is on. So it's going to probably use, I mean, these SSRs are 40 amp each, and this is a 40 amp MOSFET. So I definitely took the proper precautions by getting high amperage everything, and the wiring is high-end wiring. This is all security wiring. It's shielded with both a metal wrap and obviously the outside insulation, but it's heavy, thick copper wire. Even though it's not a high gauge, it's what it needs to be for what it is. But that's on the low voltage side. That side. Then I have, you know, number 12 wire on the higher voltage stuff. Even the 24 has number 12. So it's if you're not familiar, number 12 is 20 amp wire. So it's for a 20 amp breaker in your house. That's what you would use. So for 24 volt, it's overkill, but not at high amperages. It's not. So anyway, that's why I used a heavier gauge wire. So that's that. It's about to be printing today, so it'll be printing. I'll have both the beacon and the mechanical switch, because I have two configurations, which I could just obviously comment it out, but the easiest way to do it is just remove one and add the other back in, and I have them both on the computer. I can just upload it real quick from any computer on OneDrive, and then that's that. It has the right configuration with or without. So if I'm doing a really high temperature printer that's hotter than the beacon can take, I can just pop it out, switch the printer config, and boom, I'm ready to go. So I may do the clicky probe later, but I may do that in the Voron. But the Voron, I got a nice bracket for the tap head. So this was not the one that came with it, but you know, this is a pretty good one. Chad TI CLAB. This was like $60 on Amazon. So, but it's well made. It's all CNC machined. It's, you know, I'm going to liquid cool and heat the chamber of that printer also. So the base of it, I'm probably going to cut from sheet aluminum that's 3/8 thick, rather than the whatever kind of plastic. Even though the insulation will most likely protect that. I might be able to just use that with the insulation, because this insulation is serious. It can take up to 2,500 degrees. So nothing in these printers are going to get hot enough to compromise it. So I don't see why I couldn't just use it with that on it. I may try it, and then if I have to change it, I will, but it's in a spot where you don't really want to change it. And honestly, I like having metal to screw into to mount things, because you can just tap it. All this stuff is tapped in. This is all screwed in with M3, and I went through a lot of M3 bits. I literally bought that thread tapping arm because of this job. I'll use it I've been using it all the time already on a lot of different stuff, but I did get it because of this. So it goes to show you, you know, this is all steel. This is a steel frame. This thing is 160 pounds. But that's why it's perfect for this kind of build, because it's not a lot of vibration, it has a lot of mass to it, and it's built like an industrial machine. It is an industrial machine. So if you guys have a CreatBot, it's a good investment, but you just have to invest more than you think initially, you know, and a lot more time if you're going to go this far. You don't have to go this far. It was printing well on its own when I got it. Just not my kind of well. Like, you know, I tend to go in excess with everything. So anyway, that's just my personality. But you guys, if anybody else is wanting to go that far, or wanting to get it printing the way that this thing has and is going to, then you can feel free to reach out. I'll definitely help you any way I can. Like I've always said to you guys throughout these videos, I'm no master at this stuff. This is my first custom 3D printer build. I've learned a tremendous amount doing it, because this has been an endeavor. It's been going on for a while now, and I've made a lot of different renditions and a lot of different changes and changed a lot of parts. It's been a real endeavor, more than I ever anticipated with this. But it's just about done now. So I'm excited about that, and I don't have to come back under here for any heating sources, which that's the first time that the heating's been done like that. Like, well, it's not the first time. I decided to change it afterwards. Anyways, yeah, it's almost I thought it was done one other time, so it's the second time that I've thought it was done. But I should have known myself better. And I know I'm not done right now, but I'm basically, it's not going to change. This is going to be what's down here. Everything that's here is going to be here. You don't even see the steppers. Those are the only thing that would possibly change. It just need to clean up the wiring a little bit, and that's the monitor that's going on the other one. This 7-inch that's mounted to the table is going to be for this. It already has been for this. I'm just doing what I'm doing right now, so that's why it's not hooked up. But anyways, so that's that. I just wanted to update you guys on the progress of this. I will do one more short video of this upright and printing with the beacon on and leveling and doing all that stuff, because it moves really well. I put steel lined, steel stripped, whatever you call it. There's like five or six steel wires in the belt, and it's made of a really heavy plastic. I'll show it to you. I think I might have shown it in another video, but in case you didn't see them all. So this is actually the wrong size, but this is the right size. So these, obviously you see the teeth in them, because this is 10 millimeter and mine is actually 10 millimeter, but this is the proper spacing of the teeth, which is much more important. But because the 6 millimeter will work on 10 millimeter wheels, obviously not vice versa, but the 6 millimeter has been fine. And then I had, this is some power grip, you know, nylon rubber belt, but with nylon on the whole inside is like some heavy nylon. And this is on the x-axis only, because the x-axis has a lot of fast movement, and the y-axis also does, but it's got one on each side, a belt on each side. So it's got more holding it. So because with this hard rubber, because it doesn't flex as much as this, I was skipping a step or two here and there on the x-axis when it made quick movements, really quick movements. It had to be over 100 millimeters a second, but still I didn't want to be missing steps at that speed, because I'd like to be able to print at that speed with materials that it's appropriate for. So that's why I did the rubber belt in the middle. But I know this can take the temperatures I'm going to be able to do. I'm going to have to change it from time to time, but because the heating, you know, on and off will definitely make it expand and contract over time. But so over time it'll wear out, but it's not going to have an effect big enough to make it malfunction at the time. Also, I did get a duct for the 5015 cooling fan, and now I got that done, and I ended up deciding to do a CPAP, which I am currently finishing. I'm waiting for the hose, so I have to do another one. But after all this time of figuring out which one I was going to use and which one was going to mount properly, you still can't even see it. Let's see. That's what I ended up doing. And then there's still the big bed turbo. So what I did is I used one of those big bed turbo fans, like the one that's, you know, got the duct on the bed here. I ended up putting one in, well, putting an adapter into the output part. I think it's on my desk. I ended up putting an adapter that goes right to a CPAP hose into the output from the turbofan, which I'm going to mount right there behind the printer, and that's going to have a hose going up into the printer, and it's going to go right into it. I'm probably going to put like a double barb fitting on it and put it into the actual steel. I'll drill a hole and put it right through, and I'll fit it to the outside with a larger hose so I can get more flow, and then I'll reduce it to a CPAP size on the inside, and that'll go to the tool head. So I'm going to end up having to modify that, but other than that, nothing else is getting modified again, other than, you know, that, and then possibly the steppers, like I said. But that means I'm very close to done, because I've already been through, I've troubleshot just about every aspect of this printer. Multiple probes, multiple cooling systems, multiple fans, multiple everything, and now I'm really content with where I'm at with it. So that's a good thing, and that's why I'm sure that I'm not going to be modifying too many other things and nothing else major. The extruder's been modified, been changed, which I'm happy with this extruder. It's working good. It's not clogging. I have enough cooling on it. It's working well. And the other extruder should be great on the boron. So I'll do one more video when this is done, and this is actually going to be the last one next, because it should be done. It should be completely done. And then, well, I might do one more after that printing with peak, because I'll test it with like PPS or something. I want to start doing a really higher temperature, because PPS is pretty high. It's like over 300. Anyways, so I'll probably try that, and then the chamber is supposed to be pretty hot too, because it warps easily. I'll probably do the high temperature nylon, and then after that, I'll do another video later down the line printing peak to show you guys. But I'm going to be done with that after the PPS, and I'll do some videos about the boron. And also I got to do some more air gun stuff for my air gun guys. But anyways, I appreciate all you guys watching. I hope I was able to help somebody. I know a few people reached out about the build and parts, and I've tried to be more descriptive about the parts. So like for instance, the Meanwell power supply I use for the 48 volt is an LRS 15048. And then these MOSFETs are, I forget the name of the company, but if you just Google or look on Amazon for, actually I'll attach some links. It begins with an F. It's like Fiosec. I'm probably wrong. I'll just attach the link. And they're 40 amp MOSFETs. I did get a couple of them because I figured I might need one on the other printer, or one of my other printers if I modify those. But anyways, I got the high amperage one because of that. And these are Inkbird SSRs. I will attach a link to these. The 3 to 15 splitters, the 1 to 5 times 3. I'll attach a link to those because those are really great for higher voltage. Especially, I have a 24 volt one also, but I'm not really using it for much because I mean, honestly, I could have used it for the MOSFET, but I was using it for several things, and now I'm not, so I don't really need it there, honestly. Maybe I'll take it down, but it comes. You buy a pack of them. It comes with 5. I bought 2 because I know I'll use them on jobs also. Anyways, that's that. I'm not gonna continue rambling. I'm gonna get back to work so I can finish this and do the other video. But I will talk to you guys a little bit later. Hopefully this will be done today, and I'll be able to do a short clip of it printing a higher temperature material. It should be. I also am closing on 3 condos today, so that might get in the way, but hopefully not. So I'm going to shut it down so I can connect all these wires, tighten everything up, and put the proper monitor on there, and start taking some measurement and machining my beacon bracket. And then I'll get this thing squared away, and I'll send you guys another video later.